Okay, so one of those base cases I was talking about is when you have three mutually perpendicular flat datum features. This is when you have a very boxy shape. This means that the entire thing is a box, but you're going to have a boxy shape. Now, each of these datum features is going to create a plane that's infinite in size and perpendicular to all the rest. And then where those 3 planes intersect, somewhere over here, you can't really see it right now. There's this line right here, this line falling it over, and this one down. That is where my origin is going to be. So in these cases, typically, not always, the largest surface is your primary datum. And then you pick the smaller and smaller surfaces as your secondary and tertiary. So this was the smallest surface, so it became the tertiary. This was the second smallest, it was the secondary, and this is the largest, so it became the primary. It doesn't have to be in that order. It's all going to be based on what you're doing, but that's a pretty good way to go about it. Okay, another one you might see quite often is when you have a cylinder and a flat datum feature. Because it's not always necessary to reference 3 datum features to establish an origin and 3-axis coordinate system. You don't have to do that. So in this case, we would still have rotation about this one axis right here. But that's not really important because these 4 things are more or less symmetric, and just based on the pattern, they will be fine. They're referenced to each other, so it's not going to matter too much if we don't have that third datum to keep them from turning, because you're going to just be able to turn your datum feature simulator along with it. Also, depending on which one you do, sometimes you will actually have this be your primary and this your secondary, but that's fairly rare. There's a few cases where you might have, like this cylinder right here might be used for positioning, and that's more important than using this. Kind of like if 2 pieces are going to be connected together, one with a hole and the other one with a peg, and you want to make sure that the peg is going to go perfectly into the hole. Well, you would want to use the peg as your primary datum instead of this flat surface. But the big thing to see here is that you don't always need to restrain all 6 degrees of freedom. It's not necessary every single time. Okay, now what you'll see quite often is 1 surface and 2 features of size. So I've got this nice big flat surface that's great for primary. And I do have these edge surfaces which I could use, but in this case, because most likely this is going to be held by these different points, those features of size are going to have something in them keeping it from rotating, you're going to pick your datums based on its function. That's a really important detail here, that you pick your datums based on function. If this feature size and that feature size are going to be used to constrain this part later on, then you probably want to use them to constrain the part when it is being measured. So with all of them together, though, you will constrain all degrees of freedom. We'll be able to make our coordinate system. So function of the datums does matter. It's not 100% necessary, but it's a good place to start if you're trying to figure out how am I going to constrain this and what datums should I choose. Okay, so that's it for this time. Thank you for listening, and I'll see you all later. But if you're struggling with datums, make sure you come back to this little video so you can see how it's been done for other examples and use that on your drawings in the future. Have a wonderful day.